Hello everyone. In today's class, we're going to study a new chapter, pair of linear equations in two variables. In this chapter, we're going to see how we will be solving pair of linear equation in different methodologies, and there are few methods to solve them. And in this chapter, we're going to introduce with the new topics like how do we get a solution and what kind of a solution we're going to get. So in today's class, we're going to see what kind of a different solution we're going to get, and from that we're going to see what type of graphical interpretation we can do. So this class will be almost about the basics. So from the next lectures onwards, we can start with the different methods to solve the problems. Let's start today's class. So we all know, right, what do you mean by linear equation? So linear equation is nothing but x plus y is equals to 7. It's a linear equation. So having the two variables x and y. If I have two linear equations, then I can say it as pair of linear equations in two variables. That two variables is nothing but x comma y. Okay, so these are the two variables. So what exactly we do whenever we solve the linear equation, we will be finding the value of x and y. Then we will be evaluating whether RHS is equals to LHS. Okay. So now we'll see what kind of different solutions we're going to get for different pair of linear equations. Okay. So we'll take the first category of the linear equations. X plus y is equals to 10. X minus y is equals to 2. So now I'll consider this as equation 1. I'll consider this as equation 2. If I solve this, what is the value of x and y I'm gonna get? I have to check that. Okay. So here I'll use a substitution method. So I'll consider equation 2. So x is equals to 2 plus y. Substituting this in equation 1. So we get 2 plus y is equals to 10. 2y is equals to 8. Y is equals to 4. This is the value of y I got, and we'll see what value I'll get for the x. So x is equals to 2 plus 4. So x is equals to 6. I got the values of x and 6, and I got a specific number to the value of x and y. So therefore, the solution for this two linear equation, I can call it as it has unique solution. So whenever we solve two linear equations, and for that if I get a specific values of x and y, then we can call that kind of solution as unique solution. This is one category of the solution what we get for a pair of linear equation. So this is an best example for unique solution. Next we'll take another pair of linear equations. We'll see what kind of a solution we're going to get for that. Okay. Now let's consider another pair of linear equations. So 2x minus y is equals to 1. 6x minus 3y is equals to 3. So I'll assume this as equation 1 and I'll assume this as equation 2. Okay. So I'll consider above equation x is equals to 1 plus y by 2. Okay. So I'll mention this also. Okay. So now I'll substitute this in equation 2. Substituting it in equation 2. 6 into 1 plus y divided by 2 minus 3y is equals to 3. So, plus 3y minus 3y is equals to 3. These two goes. 3 is equals to 3. So, here if we observe, I am getting LHS equals to RHS. The property of the linear equation, we are getting LHS is equals to RHS, but I am not getting any predefined value for x and y. I don't know the value of x, I don't know the value of y, but I am getting the required condition. LHS is equals to RHS. That means if I take any values of x and y, so this equation will be satisfying. We'll see one more thing. So if I consider second equation, if I consider the second equation, so it is nothing but 6x minus 3y is equals to 3. If I divide this equation by 2, if I divide it by 3, I'll get 2x minus y is equals to 1. Now, my equation, there is no difference between equation 1 and the equation 2. Both the equations are same. That means a linear equation in two variables, correct? I have a single linear equation in two variables. Therefore, I can say it as there will be n number of possibilities of x and y values. Therefore, this will have infinite solution. Okay. So, whenever you get this kind of conditions, whenever your LHS is equals to RHS and both the equations are same, correct? So, there is no difference between equation 1 and equation 2. Therefore, we can say it as a linear equation in two variables is nothing but having n number of solution. We can call it as infinite solution. So, whenever you have a single linear equation in two variables x and y, then you will be having infinite solution of x and y. Okay. So, whenever you get a same pair of same equations, two equations, and you have two variables and x and y, then you can tell it as it has infinite number of solution. That means whichever values of x and y if you take, that will be satisfying the condition. Okay. If I take x is equals to 1, y is equals to 1, so you will be getting same. If I substitute 1 here, I will be getting LHS is equals to RHS. Here also, if I substitute 1, here substitute 1, LHS is equals to RHS. Okay. If I consider the another pair of values, so x is equals to 2 and y is equals to 3. Okay. Again, it will be satisfying the equation. Okay. So, whatever the values of x and y you take, these equations will be satisfying that. Therefore, you can tell that whenever you get the same equation in two variables, it will be having a infinite number of solution. And this is the second category. Whenever you get an infinite number of solution, it doesn't mean that the pair of linear equations are wrong. They are also correct, but their solution lies in the infinite solution. You will be not getting a unique solution. Okay. So, this is the second pair of equations. So, we will consider now third pair of equations. Okay. So, totally we got two solutions. One is unique solution and one is infinite solution. We will see for what will be the third category of the solution we are going to get. Okay. X plus 2y is equals to 4. 2x plus 4y is equals to 12. Okay. This is the equation 1. This is the equation 2. I'll consider equation 1. X is equals to 4 minus 2y. So, substituting it in equation 2. equation 2, 2 into 4 minus 2y plus 4y is equals to 12. 8 minus 4y plus 4y is equals to 12. So now what we are getting here, 8 equals to 12, which is not at all possible, correct? It is not at all possible, and it is not satisfying the condition LHS is equals to RHS. Therefore, I can say that this pair of linear equation has no solution. Okay. So this pair of linear equations will not have any kind of solution. Okay. So now totally we found three categories of the solution. One is unique, infinite, and the no solution. Okay. So we'll try to get it, what exactly we're going to get it in the graphical interpretation. Then we'll form a table for a general form. We'll take a general form of a linear equation when we'll try to create a table for that. Okay. So now how many solutions, different solution we got? We got three different solution. One is unique solution, correct? So if I want to represent it graphically, because graphical representation is also very, very important. Whenever we take a linear equation, we'll try to represent it in graphical form and then we'll try to get the solutions, correct? Whenever I take a two linear equations, if I got a unique solution, how the lines will look like in a graph sheet, both the lines will be intersecting each other. They will be intersecting, okay, or they will be intersect with each other. So this is for the unique solution. That means if you take two lines, they will be intersecting, and this is an intersecting point. Okay. Next, what we have a infinite solution. For infinite solution, it will be coincident. That means you have two lines, but both looks like a single line. Either it will be in this form, like this is one line or this is one line. Otherwise, both the lines will be on each other. Okay, both the lines will lying on each other. And third is no solution. In this one, the lines will be parallel. They will not coincident. They will be not intersect also. Now, if I take these two sets, I can call it as consistent, and this will be an inconsistent set. Okay, the no solution will be an inconsistent because they are parallel lines. Okay, so now I'll consider general form of the linear equations and I'll try to tabulate them so that it will be easy to remember. Okay, so what is the general form of the linear equation? It is nothing but a1x plus b1y is equals to c. Okay, I have two linear equations, a1x plus b1y is equals to c1, a2x plus b2y is equals to c2. Okay, now I'll be creating the table for having solution, no solution, and infinite solution. Okay, for that, so what is the condition? I can consider any pair of linear equation. I'll be assuming this only. So first, if the condition is a1 divided by a2 is equals to b1 by b2, then it has unique solution. Sorry. If a1 by a2 is not equal to b1 by b2, then it has infinite solution, and in graphical it is intersecting. So the lines will intersect. Okay. In the second condition, by A2 is equals to B1 by B2, which is equals to C1 by C2. Then it will be infinite solution and the line will coincident. Okay, and the third category will be A1 by A2, which is equals to B1 by B2, which is not equals to C1 by C2. Then it will be no solution and it will be parallel. Okay, so this is the tabulation by considering the general form we can get. Okay, so if the coefficients of x and y are not equal, then it is a unique solution and it will get intersect. If the coefficient of x and y are equal, then you will get infinite solution and it will be coincident in graphical representation. If your coefficients of x and y are equal but it is not equal to the constant, then you will be getting no solution and it will be parallel. So if you have a doubt, we will take the equations. So what was the first category of the equation I had? X plus y is equals to 10, x minus y is equals to 2. Now 1 by 1, which is not equal to 1 by minus 1. Correct? I will get 1 minus 1, which is not at all equal, and I am getting the condition satisfied. Okay. When I took the second pair of equations, so it was 2x minus y is equals to 1, 6x minus 3y is equals to 3. So 2 by 6, which is equals to minus 1 by minus 3, which is equals to 1 by 3. Correct? This minus goes 1 to 1s are 3s are. So 1 by 3 is equals to 1 by 3 is equals to 1 by 3. Correct? So this condition is also satisfied and I got it as infinite solution. Let's consider the third pair of equations. Two x plus 4y is equals to 12. Correct? So now 1 by 2, 2 by 4, 4 by 12. So this is 4 by 12 is not equal because this is 1 by 2. This is also 1 by 2, but this is 1 by 3. Okay. So now this is also, this condition is also satisfied. So whenever you get a pair of linear equations and you have to solve the problem, you might getting confused what kind of a solution I'm getting. First verify them, whether first only you can guess whether you are getting a unique solution, infinite solution or no solution by remembering this. Then you can easily solve, because you know you will be getting a unique solution but you are not getting a correct answer. You will be getting a hint whether I get a unique solution or no solution or infinite solution. Okay. So similarly in the graphical form, whether you are getting intersecting, coincident or parallel line. Okay. So this is about the basic. This is about the basic for pair of linear equation in two variables. How do you solve it? So what kind of different solution you are getting, and in how you will be representing it in the graphical form. How exactly they look, whether they will be intersecting, coincident or in parallel form. Okay. So this is all about the basics and today's class. In the next class we are going to study about the how to solve the different methods of methods for the linear equation. So like graphical method and algebraic method. In the algebraic method we have a different methods. So there we can see what kind of different type of solutions we get. Either we get a unique solution, infinite solution or no solution. Okay, so in the next lectures we're gonna further study about deeply how to solve them in graphical method or in algebraic method. I hope you guys have understood today's basic session of the pair of linear equation in two variables. Thank you so much.